Hey guys, welcome back. Thank you to everybody who was able to successfully figure out how to work this stuff last week. I really appreciate it. We did pretty well in Algebra 2. Um, Feel free to send me an email if you have any questions at any point this week. We can set up a Zoom if you're having struggles. This week's a little bit harder. Let's start by just diving right in. All right, so we're still dealing with exponential equations. So that just means that the variable is an exponent. So it doesn't matter what the base is. With the variable, the letter is going to be the x or y or whatever. A just represents some number. It's always going to be some number. It can be any number to the power of x or the power of y. And so to solve them, we need to get the bases to be set equal to each other. And so that's what they did down here. 6 to the power of x and 6 to the power of 4. They're both base 6. So it's almost like the bases cancel out and you just get x equals 4. Now, it won't always be that easy. We'll have some steps to get to where the bases are the same. That's what we want. We want to make the bases the same. And that's how we're going to start. That's the first way we're going to learn how to solve these exponential equations. Again, exponential just means the variable is in the exponent. So basically, these are the three kinds of ways you're going to see in the homework how to solve these. The first one is what we just talked about. It's like the easy one. We like it when that happens. They're both base 5. So it's almost like the bases cancel out and you get x equals 3. That's your answer. You're done. You're good to go. Awesome. Number 2 here says when you must convert one base. And so 2 to the power of x plus 3 equals 4 to the power of 5. Well, I want it to be the same base, and 2 and 4 are different numbers. But I know, because I'm a smart human being, that 2 squared is 4. And so I'm going to change 4 to 2 squared like they did. Where's my mouse? Right here. And then because you use the power of a power property, 2 squared to the 5th power becomes 2 to the 10th. And so now you can solve it. We'll show you how to do that next. But now, mostly importantly here, you have to know how to set the bases to be the same. And then the last example, we'll have one or two of these maybe. This is by far the trickiest one. All right, they gave you a super tricky one. I would never think that you would know 243 is 3 to the 5th power. But it is showing you here that they had to make them both base 3, so 3 squared, and then times the 2 by everything, 4x plus 2, and then 3. Remember, anytime it's on bottom, you just flip it to make it positive. So we're in the opposite here, because it's on bottom, it's a negative exponent. And so 3 to the negative 5 is 1 over 243. And they're just getting the bases the same. That's the trickiest one. Hopefully it makes more sense. I'll do an example of that here in a little bit. This I'm showing just for purposes of ACT, SAT. All right. We're not going to have any examples on the homework with graphing, but I do want basically always remember that the point where they cross is where they answer. All right. And so that's if you're going to take eventually the SAT or ACT, just knowing that basic rule of math is where the two, or they have 3 different graphs at the same time, where they all intersect at the same point. That's my solution. So in this case, we're talking about the x coordinate being the solution, so the x would equal 2 would be the answer. Again, we're not going to have any of these on homework, so I'm kind of skipping through a lot of that, but I wanted to put the slide here and just talk about that brief example. All right, so let's break this up here and try to learn some of these exponential equations. So we have 2 to the power of x equals 2 to the power of 50. That's my first example. They're both base 2. Base 2, base 2. And so it's like the bases cancel out. I'm just left with x equals 50. Done. Winner, winner, chicken dinner. 23 to the power of 3x equals 23 to the power of 18. Right? That's supposed to be an 18. They're both base 23. Base 23, base 23. And so I get 3x equals 18. And then I get x equals 6. I want to insert a page here to keep going. And so our next example, let me check it here, was 5 to the power of x equals 25 to the power of 3. So let's write that out. 5 to the power of x equals 25 to the power of 3. Now, they're not the same base, but I know 5 squared makes 25. Right? Or if you had a calculator, you could keep trying it. 5 to the second, 5 to the third, 5 to, does any of those make something that's equal to 25? Well, yes. So 5 squared is 25. Still a 3 on the outside. So it's 5 to the second power to the third power. 2 and 3 are both powers, so I multiply them together. So it's 5 to the power of x equals 5 to the power of 6. And so x equals 6 because they're both base 5. Again, it's kind of like the 5s, the bases cancel out. And it's just x equals 6. The last example here was 9 to the power of x plus 4 equals 81 to the power of 3x plus 7. Right? Again, I just happen to know that 9 squared makes 81. If not, I got to try that in my calculator. 9 to what power possibly makes 81? Right? 3x plus 7. And so now I got to work with that right side where I got all that going on over there. I got 2 on the inside and 3x plus 7 on the outside. So I got to multiply. When I multiply, I have to distribute. So it's 9 to the power of 6x plus 14. And so now the bases cancel out. So there's no 9s anymore. I get 5x equals negative 10. By minusing 1x to both sides, I minus the 1x over. I minus the 14 over. All right, and then I get divide by 5 both sides. I get x equals negative 2. Right. That's about as tricky as I'm really going to ask that we get that third case that we saw earlier. I think I tried to avoid those. I'm trying to remember if there's one on the homework or not. And so these are examples now from the McGraw-Hill website. I just copied them over. They're trickier for sure. So let's talk about them. Let's make sure we're all on the same page here. All right. And so 4 to the power of 5x plus 1 equals 64 to the power of 7. So I took my calculator, I went 4 squared is 16. 4 to the third is 64. So that's the first thing I did. I left that side the same, but I made this side 4 to the third to the 7th. And so really now I have 5x plus 1 equals 21. I get 5x equals 20. I get x equals 4. And again, going through that there, I minus 1 to both sides. I divide 5 to both sides. I get x equals 4. The bases here basically cancel out. 3 times 7 made the 21. B over here is a little bit trickier. Right? This becomes 2 to the negative 1 power. That's 1/2. Still have the 4x minus 16. Equals 2 to the 4th power. That's 16. Right? And then it's 2x minus 5 still there. And so I had to convert. This is that third case. This is when it's tricky. I had to convert both of them to base 2. Now I have to distribute. Negative 1 times 4x is negative 4x. Minus 16 turns into plus 16. 4 times 2x is 8x. 4 times 5 is 20. And so now I'm at negative 4x plus 16 equals 8x minus 20. The base 2's cancel out. And so I just got the exponent. So now I have to solve that. Negative 4x plus 16 equals 8x minus 20. Add 4x to both sides. Add 20 to both sides. Divide by 3 on both sides. And I have my answer, x equals 3. Again, their two examples are pretty tricky. So if you were able to follow along on those, you're going to be good to go, I think. You can obviously rewind and play it back if you need to. Now here we have 2 for you to try. All right, so give it a try. You can pause the video here and see what you get. All right. Hopefully you've unpaused the video because you've given it a try on your own. I want to get going here on trying to show those here, how to do this. And we get x plus 4 equals 18 over here because the both base 5 already. And so we get x equals 14. Over here, we're going to make them both base 2, which the left-hand side already is, but this side becomes 2 squared. And so I get 4x minus 2 equals 2x plus 16. Again, here you had to distribute 2 times x, 2 times 8, minus the 2x to both sides. Add the 2 to both sides. And then you end up getting x equals 9. So hopefully you were able to get that and figure that out. All right, so the next thing we have here is called compound interest. The most simplistic example of compound interest would be if you take money and you put it in a savings account and you just let it sit. And I use that, it was kind of the same example as last week's rate of change, but in a bank account, most times it's compounded more often than the once a year. And so we add the variable here that it's the number of times it's compounded. All right, number of times they actually apply the interest rate. And so the n here is this n here is the new part to this equation. All right, and so the number of compounding periods. Right, and so if it says it's monthly, if they say it's monthly, then n would be 12. If they say it's quarterly, then n would be 4. If they say it's daily, then n would be 365. And then I'm trying to think. Those would be the most common ones. It could say yearly, and n would be annually, and n would just be 1. But I don't think we have any examples. I believe both examples in the homework are quarterly, where n is going to be 4. Let's look at an example of this. All right. And so we need to use, again, this is the key formula here. This is the key formula. All right. I'm going to use that formula. So I have to know A, P, well, A is what I'm trying to find. So I have to know P, the principal, that's the initial amount. R is just the rate, interest rate. Remember, it's the percent as a decimal. And we just talked about T is the number of years. And so we Luciana deposits $1,700. And so that is my principal. The interest rate is 1.8%. All right. So R is 0.018. Compounded monthly. All right. Remember that was my N is how many times it's compounded monthly. My N is going to be 12. And then the time was 5 years. And so that's the first thing I need to get is all of those numbers that I'm going to plug into that equation. And then we plug it in. P is 1700. The rate was 0.018. N was 12. N was 12 again. T is 5. Now I would probably make that 60, I don't, it's all depending on you. You could do, you might do the work inside the parentheses, but you're going to type it to a calculator. Calculator is going to tell you the answer. In this case, the answer was $1,859.97. So a very small interest rate. Now this would be like a very basic savings account. You have to be a little more risky to get a big amount, but she made $159.97 for doing nothing with her money but putting it in the bank. All right, you try. You can pause the video here. I'll talk about it in a second, and I'll even talk about kind of a shortcut in case you don't know how they got the 0.005. Pause now if you need to. All right, hopefully you were able to give that a try. Hopefully you have a guess, A, B, C, or D. All right, and so let's talk about some things here before we really get going here. This is my principal. All right, that's the amount. This 0.018 is my interest rate again. Daily is my N is 365. Right? And so, boom, not going to be that one because there's no N in 365. Not going to be this one because the principal is 2,500. And so it's got to be A or B, right? And so I have 0.018 divided by 365, right? Ends up being a really, really small number rather. And so B here is my answer. 0.0005 is the 0.018 divided by 365. Hopefully my explanation of eliminating two choices, and then I knew it was going to be small, so B was the most obvious. I don't even know that I would use a calculator. Hopefully that makes sense to you. So this looks a lot harder and scarier than it is here. Inequalities is just the last few slides here, but really you're just doing the same thing that we were doing to solve them at the beginning. You're just now, instead of using an equal sign, you're using a greater than or less than sign. And we're just going to look at these very briefly. We're not going to do very many of these. But now instead of x equaling 7, it's just x is greater than 7 because it's not an equal sign, it's just a greater than sign. Again, we want the bases to be the same. Once the bases are the same, it's like they cancel out. And so we're going to look at examples. Everything we do with this is going to be power of 10. If you move on to math or science and you use this kind of stuff a lot, you'll see that 10 happens a lot. Base 10 happens quite a bit, especially in science. And so we're just going to look at examples of these tricky ones, our base 10. And so this is already set up here as 10 to the power of x plus 2. And it's greater than, and I just need to make that right-hand side 10 something. And so it's 100,000 right now. 100,000 has 5 zeros. So it's 10 to the power of 5. That's how I think of it. You can do it on a calculator to check if you want. All right, x plus 2. Now they're both base 10. So the base 10s like cancel out. It's just x plus 2 is greater than 5 minus 2 to both sides. X is greater than 3. That's my answer. I'm all done. That's as tricky as we're going to get with these. We're not going to do a ton of inequalities. That is the lesson. Hopefully you found this video. Hopefully you were able to take something away from it. There's 8 problems, I believe it is, to try on the McGraw-Hill website. Again, I'll link it to the Google Classroom, but the link won't work because you'll have to log in through Clever. All right, so make sure you go to Clever first to log in and give that a try. Again, this is a little bit trickier, so I hope you're not watching this on Sunday night. Hopefully you've given this a try during the week and you're done. There will also be that little Kahoot quiz and a discussion for this week as well. If you have any feedback on how this is going, feel free to shoot me an email, guys. Take care.